Okay, good morning. Happy Friday. First thing I want to do this morning is address some direct questions that I got via email. I was asked, a number of people actually, in class, as well as a couple emails, have expressed a little bit of confusion over uh, earlier in the week when we first started looking at limits and looking at graphs. Some students were confused on what to do when there was just a picture and unsure on how to answer these questions. So we'll take a look at number 25 and 26, which were problems that I assigned you. And here we go. We've got this picture. I've blown it up here a little bit so you can see it better. First question they ask is, what is f of 1? Now remember, this is function notation. That 1 has replaced the x. They're telling you that the x value is 1. What is the output? What is the y value when x is 1? So we're looking at this picture. We're looking at when x is 1, and we look above that, we see a lot of things going on here. We have this kind of parabola shape coming in from this side. We've got this shape here, which to me resembles a square root of x graph from this side. But when we look at an x value of 1, and they gave us this nice blue dotted line here, to me, right here, we've got an open circle, which means this part of the graph does not exist when x equals 1. And if we look from this direction, we come from the right-hand side, we also have an open circle here. Well, we do have a closed circle, okay? And that circle is at a y value of 2. So when x is 1, the y value of the function is 2. And I'm sure if we drop this down here, it's going to tell us, yeah, the answer is 2. How do we get rid of that? Over here. There we go. The second question now that they ask us is, what is the limit of our function as x approaches 1? Remember, limit is defined as the value that your function approaches from both the left and the right. So think about this, and I'm using the pointer here, but you think you could use your finger at home or whatever you want to do. As you trace this graph, and we get closer, remember, here's our x value of 1. Think about invisible vertical line here. As we get closer and closer to an x value of 1, what is our function, our y value, getting closer and closer to? Bottoms out here at 3, and then it starts to increase, and it looks like it's approaching a value of about 3.5. It looks like what we're getting close to as this graph gets closer to 1. But it never gets there because we have that open circle. On this side, as we trace our graph towards an x value of 1, we're getting closer and closer to a y value of 1. Now, this side is approaching 3.5. This side is approaching 1. They're not approaching the same value. So this is an example of differing behavior, and our answer to part B would be that the limit does not exist. Limit does not exist. The function approaches 1 from the right side, but it approaches 3.5 from the left. Okay? We've moved further down. Now we're talking about an x value of 4. So as we look at an x value of 4, clearly above that there's an open circle. F of 4 does not exist. We do not have a point, a y value, when x equals 4. However, if we trace this graph from the left side, we're getting closer and closer to a y value of 2. If we trace from the right side, again, we're getting closer and closer to a y value of 2. So our graph is approaching the same location from both the left side and from the right side. And therefore, our answer to part D, the limit of f of x as x approaches 4, is going to be that y value of 2 that we're getting closer to from both directions. The question is, what is this problem trying to illustrate to us? Well, if we think of A and B as one part of this problem, because they're both dealing with an x value of 1, what we're seeing here is that while the point f of 1 does exist, the limit as we approach 1 does not exist. When we look at part C and part D, f of 4, the actual point when x equals 4, does not exist. However, the limit as x approaches 4 does exist. So what we're really illustrating here with this problem is that the existence of the point f of x and the limit as we approach that x value are not dependent on each other. We can have a point, but not a limit. We can have a limit, but not a point. They are independent of each other. We can jump now to number 26, which has a lot more going on. Just grab this and drag this a little to the right so we can see the questions a little better. So they give us considerably more complicated graph and more questions to ask, but it's really the same question. What is f of -2? Well, at -2, we see this blue dotted line. That's a vertical asymptote. The answer to letter A is does not exist. There is no value at -2. Is there a limit as x approaches -2? Well, this side decreases towards negative infinity. This side increases towards positive infinity. We've got differing behavior. And again, anytime there's a vertical asymptote, the answer would be the limit does not exist. So both A and B do not exist. The point does not exist. The limit does not exist. Letter C, f of 0. Here's 0. We look above it and below it. We see a closed circle at 4. The answer to letter C is f of 0 is equal to 4. Limit as x approaches 0. Well, if we approach from this side, we're coming down towards 1/2. We approach from this side, we're approaching positive 4. Different numbers, we're approaching different locations. Think about it this way. If you took your fingers and traced from left and right, your fingers would never come to the same location. Your fingers would never hit each other. So answer to letter D, does not exist. Letter E, f of 2. We look at x equals 2. We see an open circle. There's no point there. Does not exist. Letter F, limit of f of x as x approaches 2. Well, if we trace from the left side, we're approaching a value of about 1/2 if we think about where this is. If we trace it from the right side, we're also coming to that same location at approximately 1/2. So our answer to letter F, as x approaches 2, your function approaches 1/2. Letter G, f of 4. Again, we have a closed circle there. That point does exist. That's at a value of 2, so the answer to letter G would be 2. And finally, the limit as x approaches 4. Again, we trace from the left. We're moving up infinitely. From the right, we're moving up infinitely. This is unbounded behavior. While there isn't a vertical asymptote here because the point exists, it's still unbounded behavior. It will continue to grow infinitely. Our answer to letter H will be does not exist. So I hope that clears up questions number 25 and 26. And thank you for tuning in.